taking a departure from, I guess, more functional OP paradigms and get into what we'll talk about as reference semantics and modify in place. So today we'll learn about creating R6 classes. We'll recognize the main R6 properties. There's many, but we'll go over the main ones. And then we'll assign R6 methods and fields, both on creation and after the fact. Then we'll compare the different R6 fields. And there's three different types we'll go over. We'll show some R6 inheritance patterns and implement R6 finalizers. And this R6 package is what we'll be using. Pretty much just one function from the package. Okay, so classes. So an R6 class creates the R6 reference object. So a very simple example, that make just add empty as a class name. It's really it's an environment, like you see, the way that it's printed. It has a parent environment. There's some other attributes. But essentially, it's an environment that you can manipulate in different ways. Every R6 object has an S3 class that reflects its hierarchy of R6 classes. So in this empty R6 class, you use a new method to create an instance of that class, and you see that there's the empty keyword, and then R6 is I guess the S3 class. The reason why you can like just type E in this case and then they print it. There's a print method for this R6. I guess generic or prints the generic in that case. So, and now, and now we'll go over some properties. So the main one is R6 objects have methods and not generic. So, here, for example, if I make in the book chapter, you have an accumulator object. So add is a method of this object. You can't use the method add or the field sum outside of this class. So this is an example of encapsulation. Whereas like uh, in other places you can use like generics if you want, but yet it's the use of add and sum are totally contained in this object. And yeah, so R6 objects have reference semantics. And what that means is that if I were to create a new accumulator, use the method advr, and then look at the field sum and the object I get for as expected. I can create a new object, call it y, and then the sum of x and y, they don't equal, they're different because the sum field in both objects are different sums, but I could use the method clone to copy the object x, and then I get the same sum field. And so, uh, again, the fields are kind of contained within the object. Only one note is that you can clone deeply an object in case you have another R6 object as a field or what have you. Just if you want to copy anything that's nested. Okay, so R6 methods can be a chain resembling the base pipe syntax. So to do this, you want to make sure you return the self invisibly. And so the first one is not as reasonable, but you can see that X dollar sign add 10, dollar sign add 10. And then you get sum is 24. Whereas I could also put these on new lines. There's from the X object, I add 10, I get sum. It's 44 because I did this twice. And because of reference semantics, the sum field is the same. So it just keeps getting added to it. But you can see that it resembles the base pipe syntax and improves readability by putting the methods in separate lines. You can do this if you invisibly return self at the end of your methods. All right, so let's talk more about methods and fields. All right, so the print method, you can modify the print method from the default. We already saw the default printing has a particular characteristic from the S3 generic. You can modify the print by including a print method in the R6 class instantiation. So I could say, okay, my pretty accumulator object, I could say the current sum is this, and then I can visibly return self. And so when I create a new object of pretty accumulator, I can, for this object, two, and then I can print. And I don't have to do print this way, but chose to be verbose. And so the way that the object is printed, it looks the way that I declared it. And so you can override the default behavior by including a print method. Same thing with initialize. So I'm sure you've seen initialize. This overrides the default behavior of new. So I could not include initialize and it still works. Still a new method, but I can also create an initialize method that whenever the new method is used, like the name Nick here would be as input, would check is the character, is it length one? If it is, assign the field name and then return invisibly self. I've seen this last invisible self line not needed. I just included for you know velocity sake. But you can see here now with the initialize method, I can create a new person with Nick, but I can't with 42 because the initialize method kind of takes over and checks if it's a character. Okay. Okay, so now instead of making a method in the um, class structure itself, you can use set to assign a method after you have already created the R6 object. And keep in mind that when you use set, only those objects that were created after the set assignment would have that method. So just keep in mind using this. But yeah, you can see here now I can set public, some field and public add field to my accumulator 6 class in case I want to dynamically create these things, which could be useful in some cases. Okay, so talk more about the different R6 fields. So there's private and public and active fields. So private fields, you can't access private R6 fields, or if you try, it yields null. So here is an example of a class called transaction, that, you can deposit or withdraw, an arbitrary amount. But you see that there's a private list of, who's the owner, and then also the balance. So if I try to get the owner field, then I get null, in this case, because it's private, the user cannot access this. The developer can, the user cannot. Then for public methods like print, they can reveal private fields. And so, like I said, the user cannot access, but the developer can. So, though I can't access the balance, I could still do some stuff and, I can get public fields like the last transaction. But if I, just print the object instance T, then it will show this private field because the developer, myself right now, just allowed that. So you as a developer are empowered to use private fields as you feel the user should have access to certain information or not, which can be pretty powerful. In case you have like a person object and you have some private information about them that, you don't want the user of your object should know, but it's still useful to you as a developer of like an app, for instance. Okay, active fields. These, and please correct me, but the way I think about it, active fields, they hide complexity, so they can hide complex method calls. This is an example from the chapter, the method, and well, I guess it still is. It's both a method and a field. It's a method for the as the developer creates it because it would take a value and give something, but for the user, they would access the random as a field, and then every time they access random, it would be a different number. So like you see in the random, method construction, then if value is missing, which it is if you try to access it, like with the field, like so, then it gives a random uniform, a number from a random uniform distribution. I don't think I have an example, but you can assign random, with a value. But in this method, if you try to assign, it stops you and says, can't assign the random field. Maybe in other cases, other methods you may make, you may allow it, but in this case, this random method really acts as only a field that you can access. You can't set it. So this is kind of an interesting case. Let's say, for example, you want to set an active field. Let's say you want to give it a username or something. There could be some very complex logic, when a value is given, that sets some other fields or what have you. And that might be pretty powerful. So that the user doesn't have to think about that complexity, abstract it away. So another use case of active fields you can hide complexity, like validating user input. So again, here's an example of a person class. I have some private fields, and I can say like, okay, these are my active, methods, fields. I'm not sure how to call them. Um, but These will access the private fields. If you try to access these active fields. And so, like for example, if I try to assign a name, well, let me go down here. So, create a new object, Nick with my age. I can access the name, and I get Nick. But if I try to assign the name, if I change that object, then it won't allow me. It would say it's not a character because that was part of the declaration. It stopped if it's not a character. So the active field in this case is validating whatever is set, which could be useful, in a complex dynamic application or something. Same thing with the age. Right here I say, okay, you cannot set the age actually. No, so again, active field can uh, direct user behavior and the usage of your objects, your code, essentially, which can be powerful in some situations. Okay. Now let's talk a little bit about inheritance. I think there's one slide on this. So you can set the argument inherit to allow provided behavior from existing R6 classes. So the example from the chapter is I want to make the add method from accumulator more verbose, chatty. So I can say I can make this accumulator chatty. The accumulator chatty class. I can inherit. I want to use this. I want to add in the same way as this accumulator class. However, I just wanna like say what's going on. I wanna say I'm adding this. So I can do that. I can override the add method, but I can still use the add method from my accumulator by using the super. Um, I don't know what this is called. But if I do super dollar sign add, that will use the add method from the inherited object. And then same thing with fields. So the sum field from accumulator, that'll also be there for accumulator chatting. So I can make something more specific, but still inherit the benefits from other classes. So an example, when I make a new accumulator chatty object, I can do the same things as I would with accumulator, but now it's more verbose. When write the code at 10 and like says adding 10 and so on. But the main logic is essentially the same. So the last thing, blasting through this, the last thing I have here is talk about R6 finalizers. And I think of these as like cleanup duty. So finalize can let you delete or unlink anything when you created your R6 object. So for example, I make a class called A, then I can just make a finalize method, and say let's say something, like finalizer has been called. Very simple. Something I noticed that I needed to do here that I didn't have to do before. I think it was before 2.4 or some R6 version was, well, one, I had to put the finalize method as a private, I guess, method. Um, but I didn't have to do that before. Which makes sense, I guess. No user is gonna use finalize. Really. They're gonna just use RM, on the object or exit the app or something. But also, you have to call the garbage collector like explicitly, or else the finalized method won't be called. That I never had to do before, but I guess it's more efficient. I know know you can know ahead of time when the garbage collector will be called, but I guess it's more efficient to, the finalize when absolutely needed. So like there's not an expectation of not using object and then that finalized method being called. Yeah, the garbage collector has to be also called. So that was something new I learned from the chapter. Because the chapter had that warning. So that was cool. And yeah, that is the end of my slides. And sorry if I blew through this, but I haven't been to discuss with anyone about our six subjects.
Surprisingly short. Um, Something that uh, I'm curious about your opinions about is that the last section, like other than because it looks more like other programming languages. Um, and sorry, not in your slides, but in the chapter, they have the YR6 section, which a lot of it is why does this exist as opposed to RC, and no one cares about RC, so that's not really an answer or a question worth answering. But like you know, when do you use R6 other than when you're working with something like Shiny that is written in R6? Do you have a feel around that, or do people have any thoughts?
Hmm. So, John, I've used R6. Few years ago, I was doing a web scraping project and interacting with an unofficial like API, and I had to get a token, and the process was long running, so often the token would expire during that process. So I set it up as an R6 class with methods that when you needed that token to make a call, it would check, am I expired? I'm expired. Okay, redo the extending call, give me a new token, and then that would replace. And then that was a nice tidy way of having that token kind of be immutable no matter which part of the programming was calling it as I was trying to pull down all this information.
Makes sense. I've seen like a lot of API packages use R6, and I had never seen such a concise argument for why. Like, oh, yeah, that makes sense.
Yeah.
Um,
We use our
yeah,
six actually to so I actually had a nested R6 or I had an R6 object that would then create another R6 object that would be private because that one called an API and had private information that would delegate certain SQL statements. So it acted like a way to, ensure privacy of, like data from a database connection. This was before the rollout of the OAuth, and Posit Connect that would do this like more seamlessly. So I will say I did not know RC existed, and I feel like I don't know if R6 didn't exist when I've used RC. I don't know. I feel like the introduction of R6 was like, oh, there are like OOP options that are
Yeah.
approachable in R.
My understanding, like there's a reason he doesn't have a chapter on RC, that it was kind of a sloppy implementation of encapsulated OOP. Um, so I wouldn't recommend trying RC, although like I haven't actually tried RC myself, so who knows, maybe it's I don't know, maybe it would be useful, but there is the line that R6 is much faster than RC just in general. So um that's interesting to know. Yeah, I use it in Shiny a lot, and it makes sense because Shiny is stateful, and that's kind of a sign that you might want something encapsulated where like the object has a state that changes, and having to keep creating new objects or updating, assigning new things to the object can be messy. Um, but I don't think I ever like reach for R6 outside of a case where there's already something that's using R6, like RVest, the I don't remember what he calls it, but he has the active um HTML live. That's what it's called. It's an HTML live object, which is a web page that is stateful. So as you like click things on the web page, that object changes. Um,
Yeah.
and again, I've used R6 in things that are wrapping that, or I've used R6 in Shiny related things. But I've also like I have some cases where I use environments for things, and it makes me wonder if it would be easier. Like R6 is a fancy environment, and so if you turn to an environment to solve some problem, possible that you end up kind of rewriting parts of R6. So I need to watch out for that. I did have a case where I don't remember what it was, but I was working on something and I was like reasoning through how it would work. And I was like, oh, yeah, I could use environments to do that. And like went through this whole process. And I'm like, oh, that is R6. Like I just reinvented R6. Okay. So, um, yeah, I don't know. I haven't extensively used it. I know encapsulated OOP is like what every other programming language is built around.
Hmm.
Um, and so it's probably a nice like on ramp to thinking like other languages. Um, but I also feel like most of the times I've seen R6 used, it's like, oh yeah, this person doesn't use R. So they wanted to write something that feels like Python to them. So they wrote it in R6. Um, and I'm comfortable writing it in R. So usually that just makes it like feel weird.
Hmm.
um, it is fun to like God, I think it's in Chromote. Uh Chromote is heavily R6. That's where the HTML live in RVest reps Chromote, which is like a headless web browser, Chrome web browser. Um and it's written like some of the methods are functions that are defined outside of the R6, and they're very like written functionally. They're written in ways that you normally it's frowned upon for proper encapsulated code. But it's like, yeah, because it's written by someone who works in R. It's Garrick and Bowie from Puzzit. And so it looks a lot more functional than any other R6 based things that I've seen, which you can mix and match. You can have a method of an R6 that is it's calling a generic, and then it's going to look at the class of of self, the class of the R6 object, and use that generic. You could define it that way if you want to. It's weird to do that, but you can do that. Because anywhere where it says, like print equals or add equals function, x equals one, well, that function can just be a named function. You don't have to put an anonymous function there like that. So, but it's weird because if that function that you're calling references super or self, that other function doesn't know what super or self is normally. So, um, anyway, it's yeah,
Hmm.
it's interesting. I don't know outside of like I haven't had a thing outside of web stuff where R6 really feels like it makes sense. Because I guess, it's partly it is that whole having a state, and so the world outside it can be changing. And so anything that I guess is like that, where you want it to be kind of live. Yeah.
Yeah, it didn't seem like there was much like from a data analysis standpoint.
Right.
Like you're not really going to create objects to run your analysis through.
I could see if you have an analysis that you run a lot that is off of, a feed of data, building that whole thing as an R6 object that it's the exact same call, um, but it's hitting the live data. Something like there could be something there. I don't know. Um, and
But
then once it has refreshed, it knows that it has refreshed, so it doesn't any other calls don't have to worry about that. Something like that. I don't know. There could be something there, but I mean, I guess go learn Python and see what these are, what the reasoning is there. And then
yeah,
it might be like, oh, okay, yeah, I can see where that would be useful. Because I know there are arguments about speed related to R6 of I mean, I don't know what those arguments are. I just know that is, oh, R is all functional and that's why it's slow. It's like, it's slow because anyone can write R code. And so some of that R code is written by people who don't know what they're doing. Um,
Hmm.
but, that can happen with other languages too, for sure.
Hmm.
It's funny to me because that's how, it's how things work for almost all programming languages where like you change um, the value, some value inside of your object, and it changes everywhere that object is referenced. And that feels really weird in R that you pass this variable into a function. You don't reassign it, you don't do anything like that, but it changes because it got changed inside of that function. Um, it took some time to get used to that with Shiny of, oh, all these things are being changed. Like the thing you pass in is the thing, not a copy of the thing.
Hmm.
So anyway, yeah.
Hmm.
All right. Well, so next week I put a message into Slack that Logan is signed up to present, and they were here a couple, I don't know, a few weeks ago, but I haven't seen them around. Um, and so I might end up presenting that one. We'll see. I'm gonna try to kind of keep an eye out. So if anyone is really interested, like actually, I think that chapter is pretty short, so I don't think it's gonna be that big of a thing. Um, and yeah, so we'll do the trade-offs. Yeah, it's a very short chapter. We actually already talked about little bits of it. I guess kind of talking about bits of it right now because R6 versus S3 is a section of that chapter. So good. I'm actually really looking forward to seeing that. Um, and then trying to see what was the schedule like. Yeah, we'll do the like introduction to metaprogramming, chapter 17 and plus all the stuff like the introduction to the section. We'll do that on the 16th. And again, I'll ping this Martine because oh nope, Martine is here. Cool. So hopefully you will be ready in 2 weeks, Martine. Um, we'll do that, and then we're going to take the following 2 weeks off. Uh, and we're still very much on track to finish just before daylight savings spring forward time, which is the worst because US and Europe are like 3 weeks apart on that, something like that. And so I really want to finish before that. Um anyway, all right. Um yeah, I just shut the clubs down when it's time for that switch because inevitably when we try to run them, people, get confused and then we have two clubs on top of each other. So all right. I'm going to go ahead and stop